So I now hand over the session to Professor Balamuralidharan. Kindly introduce the invited speaker, sir.
Okay, sir. Sure, sir.
Thank you.
Dr. B. Kavya Sandoshi is working as an assistant professor in the Department of Electrical and Electronic Engineering at Godavari Institute of Engineering and Technology, Rajamundry, Andhra Pradesh, India. She graduated in Electrical and Electronic Engineering at Savida Engineering College, Anna University, Chennai, Tamil Nadu. She secured Master of Engineering in Power Electronics and Drives at JPR Engineering College, Anna University, Chennai. She secured PhD in Electrical Engineering at Anna University, Chennai. She is in the field of Power Electronics at Godavari Institute of Engineering and Technology, Rajamundry, Andhra Pradesh, India. She is in teaching profession for more than 10 years. She has presented 30 plus papers in national and international conferences and symposiums. Her main area of research interest is power electronics and renewable energy systems. Also, ma'am got award prize, Anna University rank holder in PG, and award winner, cash award winner at Savida Engineering College. Madam, thank you, madam. Thank you so much, madam. Thank you so much.
Thank you, sir, for
conferences. Please take over this session, madam.
Good morning to everyone. Thank you for giving an introduction and this opportunity to speak with you all and present today's presentation. Let me go into the presentation, sir. I will share my screen now. Before that, I would like to thank the organizers of this conference. That too, the topic is wonderful, recent trends. So that is what is the need of the hour. Sir, can you give me host?
Yes, madam. All are shared, madam. No issue. We share it.
Is my screen visible, sir?
Screen visible, madam, but PPT not visible.
Now is it visible, sir? Not yet?
Yes,
Not
madam.
yet.
Yes, madam. Not yet, madam.
Okay, 1 minute, sir. I'll check.
It is showing in Gmeet, madam. Gmeet page it is showing.
Okay. Yes, sir. Now I think it will be
Yes,
visible.
yes, madam. Yes, madam.
Okay. In today's presentation, we will discuss about energy management of inverter and battery in a grid-tied renewable power system. So before I even get into this topic, I would like to briefly introduce about renewable energy and what are the different types of energy available. Why we are discussing about this topic in the first place? Why is it interesting to the researchers? See, the energy which is available to us is non-renewable in nature. That is, coming to the limited resources like coal, natural gas, and nuclear energy, all these are not going to replenish naturally. That is, as the name suggests, non-renewable means it cannot renew. It is going to be limited and the resource available to us is limited. So we can utilize it only until it depletes. That's why the world is moving towards renewables. What is this renewable? Renewable means, as the name suggests, it is going to replenish naturally without human intervention. That is, even without the human being getting to do anything. The engineer's perception, if you say. So even without the involvement of anybody, the energy and the sources are naturally available to us all the time. Like if you see solar, wind, all these kind of resources are available in abundant to us. So we don't have to worry that they are going to deplete one day. That's why we are looking for renewables. That is the first reason. And there are other positives also of renewables. That is, they do not cause any type of pollution. Considering the entire life cycle of the generation process in renewable power generation, there is no pollution involved. There is no carbon emission involved. So that is one of the major aspects we are looking at right now, because the world is moving towards sustainable development goals and clean energy development. Considering the renewable energy scenario in India, so in India, already we are ranking 4th place in the world for solar and wind power generation. This is as per the statistics obtained from India Brand Equity Foundation. So as on date, that is until February 2024, the installed capacity of renewable power generation alone is 183.49 gigawatts. So we are going to move towards more installations in near future, and we have plans of moving towards renewable energy completely by 2030. So almost most of the power generation sectors from India, now we are moving towards renewables. And even for investments, that is, if other corporates need to invest in renewable energy sector in our country, India is it is in a demanding position, because coming to solar PV installations alone are more, and even wind energy is abundantly available in our country. Our country is placed in such a way that we have abundant resources naturally. So even when you consider the clean energy investments, our market, that is in our country, the market is on the booming side. As per the Central Electricity Authority report also, the total power generation is on the rising side. So starting from a decade ago, considering the statistics of a decade, if you observe, always the power generation is increasing because our power demand is increasing rapidly. Now we are using more power and we are still not having sufficient power. We have to generate more. So that is the current situation. Therefore, we are going for more power generation. And if you observe the increasing trend here, the total generation, including the renewable sources, is on the rising trend. And the split up as per your wind, solar, biopower, so different types of renewables, the split up of power generated in megawatt is clearly given here. The statistics are given. So we can observe that the total generation is more and renewable power generation is also more. Now I will show how the renewable power generation trend is going to be. So in the previous slide, we observed already that the total generation is on the rising trend. The generation growth percentage also is on the rising trend. The renewable power generation, if you observe, that is as per the statistics taken until February 2024, the installed capacity is 183.49 gigawatts. So I'm talking only about the renewable installed capacity, not the total power generation. Only the renewable power generation, it accounts to 183.49 gigawatts, which is huge. And we already had a target of reaching about 200 gigawatt by 2025, and we have already neared the target. We are going to increase it. So why we are increasing the renewable power generation rather than going for nuclear is because of the hazardous nature of nuclear and other non-renewable sources, like how I discussed in the beginning, related to the depleting nature of the non-renewable sources. We are moving towards renewable. So considering the wind power alone, 45.15 gigawatts of power is generated through wind energy alone. Like that, the split up is given for solar, biomass, small hydropower, waste to energy conversion, and large hydro, which accounts and sums up to 183.49 gigawatts. So, India is a huge market for renewable energy because of four major reasons. That is, considering the demand, the robust demand, it is estimated that the demand is going to rise up to 817 gigawatt. Can we imagine such a huge demand? How are we going to reach that target? We need to reach it step by step by going for small targets each year. Now we are in the range of 183 gigawatts, but our demand is going to be 817 gigawatts by 2030, which means we need to further increase our generation and plan to meet our demand, that is load demand. So as per the demand, rise in demand, there will be more corporate sectors involving in investments in our country. So India is best suited for investments because the demand is huge here, the population is high, and the consumption of electricity is more. Coming to the increasing investments, already there is a rise in investments in renewable energy sector particularly, and by 2085 it is expected that the capacity will be 280 gigawatts. Already we have reached 183 gigawatts. Coming to the policy support, even our Indian government, it supports us with a policy, especially Mission Innovation Clean Tech Exchange. This is one of the global initiatives that supports clean energy innovation. What is this clean energy? That is emitting or without causing any poisonous or hazardous emissions into the atmosphere, we are trying to generate electricity. That is what is clean energy. We call it as clean energy or green energy. So now the world is moving towards green energy production. This Mission Innovation Clean Tech Exchange is supported by Indian government. This is in order to accelerate the clean energy innovation. And like that, we have numerous policies that our Indian government supports for generating green or clean energy, you can say. And the competitive advantage part, if we observe, as far as India is concerned now, that is up until 2021, as per the Renewable Energy Country Attractive Index, we are on the competitive side. We stand a good chance of renewable investments in renewable energy sector. So this is as per the survey taken from Indian Brand Equity Foundation. And here we get to know the importance of renewable energy sector. Observing the job opportunities as well, more than 11 million jobs are this is as per the report from IRENA, that is your International Renewable Energy Agency. So as per the report from International Renewable Energy Agency, we have more than 11 million jobs only in the renewable energy sector. So that is going to further increase up to 24 million by 2030. So a lot of importance is given to renewable energy sector, especially solar energy is dominating among the other renewable forms. So these are some of the drivers to move towards renewable energy. As per what we discussed till now, we would have understood that renewable energy is very, very safe for the environment, isn't it? So it is available in plenty and we can make use of it, unlike the non-renewable sources. So the main reason or the main attractive feature of this renewable energy is that it does not cause any air pollution. It reduces it. And by using renewable energy, you have other benefits like reduced oil spills in ocean, and a lot of government policies are supportive for renewable energy generation. So we have some subsidies. We get some subsidies for generating power to meet our own requirement. Now, microgrids and smart grids are also available in abundance. Why the emerging trend is there in microgrids and smart grids is proper utilization of renewable energy generation within a certain community. So we can generate the required power for ourselves. That freedom our government has given, and we are able to do that effectively. These days, most of the institutions, they are generating the power required for themselves, and they are also providing the extra power generated to the grid. Thereby, they are receiving the subsidies from the government. Not only educational institutions, but a lot of companies also are involved in this type of energy sector. So on an average, compared to the existing fossil fuels, renewable power is increasingly cheaper, and it is safe for us to use. There are more positives compared to the negatives when we use renewable power. That is why today we are going to discuss in depth about one of the renewable energy, that is PV, photovoltaic cell. So what is this photovoltaic cell? Actually, it is made of semiconductor material. We know that semiconductors have the ability to trigger the flow of electrons. So whenever the sunlight is going to fall on a semiconductor material, there will be movement of these ions. Thereby, the electrons are going to be triggered, causing electricity generations. So this simple idea of power generation is used in PV technology. Generally, if we observe, these PV cells will be very small and rectangular. They will be very compact. We can go for connecting them in series as well as parallel. So two types of connections are possible. And as per the PV, the recent research in PV, efficiency has always been one of the major drawbacks in renewables, and also the availability of power, it is not continuous. So if we consider the standard power that we get from the grid, it is always available, and during the power outage alone, we are experiencing the power cuts. But for PV, there is a requirement of irradiation. The temperature and irradiation are the main inputs for your PV. So what happens is, when there is sunlight, there is abundance of energy which is generated from our PV cells. But during the absence of sunlight, we are required, or we are forced to utilize other options for our for meeting our load requirement. So during sunlight, since PV is available, we can go for other form, which is storing the energy in a battery and then utilizing it during the absence of sunlight. This is what is the research revolved around now. Because the renewable energy, be it wind or PV, sunlight is not available round the clock. During the night time, we cannot absorb any light. The PV panels cannot absorb light, meaning they cannot generate electricity. So we need to use a battery or a storage mechanism in order to go for meeting our load demand, even during the absence of energy generation from our solar module. So because of this drawback, we need to go for energy storage, and the efficiency part has always been a challenge. And now the researchers have worked on the efficiency. Especially, a lot of research is going on in materials for solar panels, like perovskite solar panels. This research is taking place in Russia. And also concentrator PV technology is in research. This is also a hot research topic. Why we are working on different materials for PV modules is to increase the efficiency of your cell and module. So as seen here in the table, we can observe that the efficiency, cell efficiency, the maximum efficiency that we are able to attain is 47.6%. That too with the use of multi-junction gallium arsenide. This material, if we use, we are able to obtain this efficiency. But most of the solar panels that we have installed till date are of monocrystalline form. Monocrystalline silicon type only we are using. And with that, we are getting a efficiency up to 27%. But what about the remaining power? Like out of 100%, we are able to extract only 27%. On an average, we can get from 17 to 25%, considering the climatic conditions, because the radiation levels and the temperature levels are not going to be constant. If you consider any simulated model, there we may consider the standard test conditions as 25 degrees Celsius and irradiance levels as 800. But that is only for simulation part. When we see the reality, we will have varying irradiance and temperature conditions. So it is not possible to attain maximum efficiency always. That's why we need to use a technique called maximum power point tracking. So I will introduce more about that in the upcoming slides. Now, coming to the popular ancillary service. What is this ancillary service? Actually, whenever we go for connecting our system, be it renewable, any form of renewable, that is PV or wind, whenever we go for connecting it to the grid, we need to take care of certain things like real power and reactive power management and the power quality. That is, the grid frequency will be 50 Hertz. In India, it is 50 Hertz. So we need to maintain 50 Hertz frequency always. So in case we are feeding power to the grid, like I was telling you, some of the companies and institutions are trying to generate electricity by their own and also feeding electricity to the grid. So they need to take care about the frequency matching as well as the voltage matching. So these ancillary services are in the ancillary services in electric power market, like black start capability, time correction. All these are going to help in power flow management to the grid. So if you take, for instance, black start means we can guess it from the name itself, start. That is, we are going to restore electric power, although there has been a temporary or partial shutdown. So even during during that situation, if we are able to restore, that is black start service. Like that, we have various services, standby service, and we have planning reserve. Planning reserve means we will go for forecasting how much electricity is required. The load demand will be forecasted. That is load forecasting. And then based on that, we will plan the reserve capacity also from our generating unit. And redispatch, that is, we will go for rescheduling. We will change the operating schedule of our power plants, that is redispatch. And power quality. Power quality itself is a very wide area. There are many power quality issues like sag, swell, harmonics. So we need to take care of all these issues when we go for integration with the grid. Integration to the power grid involves a lot of work in the background. So these kind of services are available. This is as per FERC, that is as per the Federal Energy Regulatory Commission. So these are the ancillary services available in the electric power market. Among that, now let us see what are the services provided by PV systems alone, since our focus is on PV systems. So here on the left side, what I have shown here is a multifunction PV system. That is your solar module, inverter, and battery. This is a simple multifunction PV system. That is PV, the electricity generated from your PV module, which is DC, that direct current is converted to alternating current using inverter. And this alternating current is going to be fed to the grid. But there is this PCC. What is PCC? Point of common coupling, where we have to check whether the frequency and voltage requirements of the grid are matched. There are numerous researchers working on grid synchronization techniques as well, because when we go for integration with the grid, we need to take care of even minute details. Otherwise, the entire power grid will be disturbed. Not just a single locality, but the entire power grid may lose the balance. So we need to go for carefully integrating with the grid. We need to match the grid frequency and voltage. So services provided by PV systems, if we see, like I mentioned earlier, active power, reactive power, and grid forming, these things we need to take care even before we connect to the grid. So some of the services I have given here, that is this fault ride through. So the fault ride through means even during a faulty condition, it is capable, that is electrical devices, they are capable to be connected and remain in the network. Usually what we do is, in the traditional power grid, if there is any fault occurring, the protective devices, that is switchgear and protective devices, will go for isolating the faulty section. So usually we have studied about circuit breakers and how they go for isolating the faulty section, thereby providing and protecting the grid. So this technology is an advanced technology whereby even during faulty conditions, although the devices are connected, there is a means of managing the fault and controlling the fault. And islanding, this islanding also is, this term is very popular in microgrids, because when we go for operating a smart grid and microgrid, we operate in islanding mode as well. Islanding, as the name suggests, it means that although the grid is not connected, that is, if we observe this figure, now we have a connection to the grid. From the inverter, we are giving to the grid. But in case it is not connected, still there is a power flow in this multifunction PV system. Still the power flow exists in the components of our power station. That is islanding mode. We are not connected to the grid, yet the components are powered. So in this kind of situation, the workers need to be careful and warned about the powered devices so that they can take precautions accordingly. Now, this is a simple layout of solar-based grid-tied system. First, let us see about a system without energy storage. So here, the first block which is provided is PV system. So from the PV system, we get the DC, and that DC is not sufficient for us to generate the amount of electricity required by our grid. So considering a single phase grid, a simple layout I have provided here. So here, the boost converter is going to increase the level of the voltage. A simple boost converter will boost the voltage 2 times. So if we go for advanced converters like Liu converter or other advanced converters, switch desert source, there are many converters which are available in literature right now. And recently even KY converter and other high gain converters are a deep discussion for researchers. So if we go for advanced converters, we can further boost the voltage levels. This boosted voltage will be given to a voltage source inverter. Here, what is shown is a single phase voltage source inverter, but we can use current source inverters or multi-level inverters also, which we will be discussing in our discussion in the later part. So here a single phase voltage source inverter is shown, and then we use the LC filter before we connect to the grid. So this is a basic layout and power flow between a PV system and grid. How we are going to operate our switches in the boost converter depends upon the pulses generated from our PWM generator. Earlier, I was mentioning about the maximum power point technique. So here we have P and O MPPT, which is perturb and observe MPPT, maximum power point technique. So maximum power point tracking is a way in which we are going to track the maximum power which can be extracted from our solar panels. So when we go for operating our solar panel in such a way, we can extract maximum power and the efficiency will increase. Otherwise, during the shading conditions, we would have heard about partial shaded solar panels. So during partial shading conditions, the entire panel is not going to be struck by the radiation. So what happens is only a part of the panel is going to be active in electricity generation. Thereby, the generated output is going to be very much lesser. So to handle these kind of partial shading conditions and windy conditions, we are trying to extract maximum power from our solar panels. And by using this MPPT technique, we are going to trigger the switches of our converter through pulse width modulation technique. So in the blocks, that is in this diagram, in this layout, whatever blocks are connected, we will discuss about them. The first block is PV system. So coming to the PV system, as I told earlier, a PV cell will be made of semiconductor material. So due to the flow of electrons, we are going to get the electricity. And this PV cell, the main factor to produce the electricity is irradiation. So this irradiation cannot be controlled by us. The sunlight is a natural source and it cannot be controlled by us. So the irradiation from the sun will determine the power from PV system. Therefore, what we can do is we can go for utilizing a maximum power point tracking algorithm to efficiently track the maximum power from PV and operate our solar panel to reach the maximum value of power. So in general, we go for utilizing power electronic switches, advanced power electronic converters for the purpose of converting the solar PV system and wind also. Energy from wind also needs to be processed before we give it to the grid. Like initially, the electricity generated from PV or wind will not be sufficient to be matched with the grid. So we need to go for boosting it. We will be using numerous converters during the stage of conversion. In the PV system types, we can classify into three major categories. So one is the grid-tied PV, which we have seen. The layout which I have shown is a grid-tied PV. Simple grid-tied PV layout without energy storage is what I have shown now. Next part is grid interactive or hybrid with energy storage. That is, energy storage here refers to batteries or supercapacitors or any other storage mechanism where we are going to store the electricity generated from our PV panels and also utilize them during the night time. That is the second category. And the third category is the off-grid with energy storage. Most of the citizens, they have started to go for off-grid with energy storage. The individual houses, if you observe, here, or at least in North India, most of the houses now are powered by PV. Even the water heaters are powered by PV. So depending on the solar power heaters, they are able to give us warm water. At least during the availability of solar power, we can observe that although it is slow, we are able to get hot water, warm water to hot water, but it takes some time because the process is somewhat slow. We need to improvise on these techniques So a lot of research is going on in that area also. Off-grid with energy storage means we are going to generate the electricity and use it for our own use. That is, it could be residential or industrial. We are going to utilize it, but we are not connecting our generated electricity to the grid. That is off-grid. So this grid interactive system, the main blocks involved in a grid interactive system with power backup, meaning with battery, is the grid. Grid is involved. Before we connect to the grid, we have the meter and the main service panel, and we have the non-backup loads, that is load requirement like AC or any other load, fridge, whatever loads we use, they receive certain wattage, they require certain wattage. Non-backed up loads means even in our houses, if we observe, we connect the inverters, but only for two lights or two fans operating. We do not connect our inverter and operate huge loads, like we do not operate hair dryers or grinders. We only operate two fans or two lights, depending on the inverter capacity, of course. So those non-backed up loads like air conditioners, refrigerators, and other loads which require high wattage, we cannot provide backup for that. It is not advisable for that, for us to operate them during the power outage condition. PV array, charge controller, battery, grid-tied inverter or charger, backed up subpanel, and backed up loads. So here you can see clearly backed up loads even during power outage, like how we use inverter at home. Even during power cuts, we are able to get minimum power requirement, like we are able to at least operate 2 to 4 fans at a time up to 5 hours. This is the standard one available in market now. Up to 5 hours without interruption, we are able to operate with our inverters. But still, research is required to operate for a longer duration. But for that, the battery storage is a challenge. The more amount of power stored means the space occupied also will become more. That's why we are using a minimum 5-hour model for our houses, residential applications. Coming to the off-grid system, here if we observe, there is no grid involved at all. In the previous figure, we had our grid. So the main service panel, meter were involved. The utility grid is here. We are going to supply it with the abundance or excess energy generated from our PV array. But in this case, in the off-grid system, the grid is not involved. So the generated electricity from our PV it's going to be utilized only for our uses, that is for powering AC loads and DC loads in the residence or the particular industry considered, only for a local load. It is not going to be given to any grid. That is off-grid system. This kind of system is observed even in many foreign countries these days. Off-grid systems, that is most of the residences are going for powering, meeting the power demand by themselves, generating it from PV arrays by themselves. So the second block which we saw in the layout, apart from that is after the PV system, is boost converter. As I discussed earlier, this boost converter is required in order to match the voltage levels which we need to give to the load or grid. So the generated electricity from PV, it will not match the levels of the load or the grid. We need to either increase it or decrease it depending on the load requirement. So there are numerous converters. This converter, the main function of this converter is to convert one form of energy into another. Suppose DC is converted into AC. There is a special name given to that converter. It is inverter. Like that, here we are going to discuss only DC to DC converters, where the level in DC voltage alone is going to change. That is, you can get output voltage higher than input voltage, or if you use a buck converter, you can get reduced output compared to the input. Coming to the MPPT algorithm, that is maximum power point tracking algorithm, perturb and observe algorithm. How it works? How can we get the maximum power point? How are we going to work? It's by measuring the actual voltage and current. We will get the power, because real power is nothing but the product of voltage and current. So we are going to measure the actual power that we obtain and the change in power, that is del P. So depending on whether del P is greater than 0 or not, we are going to change the levels of our output voltage. We will either decrease or increase. Therefore, we will update the values, and these updated values of voltage will be given back to the measured values. Therefore, like a closed loop system, this is going to work out the maximum efficiency. So we can get the maximum power by going for this iterative algorithm. This is the most widely used one, but we have advanced algorithms like fuzzy and artificial neural networks are also involved these days. And even MPPT techniques, if you see, there are many other types as well. Hill climbing, and there are other methods of MPPT, but the most widely used one is perturb and observe. Next block in our layout is the inverter circuit. There, in the layout, I have shown a single phase voltage source inverter, but I said we can go for using current source inverters and multi-level inverters, which we will be discussing. So after the PV system, we have the boost converter, and now the boost converter has given the adequate output DC. This DC is going to be given as input to our inverter. Now this inverter, what it will do is, it will convert it to AC, and this AC output, it can be utilized for powering our loads as well as connecting to the grid. A lot of research is taking place in multi-level inverters these days, because multi-level inverters can be used for high power applications. Generally, this inverter, it is going to convert DC to AC. Going for VSI and CSI is the traditional method, but now we have moved to multi-level inverters, where actually in 1975 itself, multi-level inverters were introduced. But the research is going on up to 98 levels right now. We have reached up to beyond 98 levels now. And what is this levels? Multi-level, as the name suggests, it's going to give us the output like a nearly sinusoidal waveform. Usually when we convert DC to AC, we are going to get a waveform like a square AC wave. So we want a nearly sinusoidal structure. So we prefer multi-level inverters, where we are able to get numerous levels tracing that we are able to get a nearly sinusoidal waveform. One of the major advantage of this is nearly sinusoidal waveform, meaning it's going to reduce the harmonics and reduce the losses. Generally, these multi-level inverters will be used in industrial applications. This multi-level inverters, since this is the area of interest, we will just see a little more about multi-level inverters. Multi-level inverters can be classified as single DC source and separate DC source. So under single DC source, we have diode clamp type, flying capacitor type, and cascaded H-bridge type. When we go for a comparison between our traditional VSIs or CSIs with MLIs, that is multi-level inverters, these are the factors which we will consider: whether the harmonics generated are more, how is the switching frequency, what are the switching losses. So considering these factors, if you observe this entire column of multi-level inverter, we can observe that there are less switching losses, there is low dV by dt loss, there is low voltage stress on switches, switching frequency is low. So there are numerous advantages of using multi-level inverters compared to your traditional two-level inverters. So this is the state-of-art survey and state-of-art review of MLIs based on their types. In the previous slides, we saw the classification of MLIs where diode clamped, flying capacitor, and cascaded H-bridge type were listed. So some of the advantages and disadvantages of each type are shown here. If we observe, the most commonly used one is cascaded type because we can go for connecting n number of topologies together. Cascade, as the name suggests, it means we are going to go for connection. We are connecting more number of sources. So separate DC sources are required. Although it is listed as a disadvantage, most preferred method of going for MLI, most preferred topology rather, is cascaded MLI type. Coming to the concept of Z source. What is the Z source? Suddenly, why are we discussing about this while discussing about the inverter module? Let me give you a brief on this. So after the PV system and the boost converter, we are discussing about the inverter where the traditional inverters, that is VSIs and CSIs and MLIs are discussed already. The Z source means we need not go for additional switches. See, when we go for additional switches, we get additional switching losses. Z source, it's nothing but inductors and capacitors connected in Z shape. So there are a lot of advanced topologies in Z source inverters also. We have switched Z source type and we have transformer based type. There are many more transformer less configurations as well as transformer based configurations are available. So we will not go for additional sources, and the main advantage of using this combination of inductors and capacitors is shoot through mode is allowed. Generally, when we operate our inverter, suppose here you can observe that T1, T2, T3, T4, 4 switches are given and the load is given. Usually we will operate T1 and T4 together. That means no two switches from the same arm, or rather the same leg, you can say. That is T1 and T2. They are on the same arm. T3 and T4 are on the same arm. So no two switches from the same arm should operate at a single time. Why? Because it causes your direct short circuit, right? The circuit will be in short circuit condition when these two switches are closed. That means the power flow, the current will flow like this and it will be a closed loop and it is a direct short circuit, which means the current is going to be high and it will cause a damage to the circuit. Therefore, in general, when we will operate T1 and T4 together and T2 and T3 together in order to achieve the AC output, that is on the positive cycle and the negative cycle. Here in Z source, while using Z source network, we have an added advantage that we can go for shoot through mode. That is, we can operate two switches of the same leg at a same time for a short time duration. Why it is allowed? Why it is an allowed shoot through mode means, see the beauty, we have the energy storage devices here, inductor and capacitor. So the combination of these energy source devices, these elements, they are going to store some excess energy and thereby they are going to take the attack caused by the short circuit. So whatever damage is caused by the short circuit is going to be compensated by these energy storage elements, inductor and capacitor. Therefore, the circuit is going to be protected. The switches are going to be protected. But during this state, we can go for boosting the voltage abundantly. So instead of going for advanced high end converters where number of switches are used and complex operation is required, we can go for utilizing a Z source network and boosting the voltage almost quadruple times. That is almost 4 times we can boost it. So the Z source networks, as I said, we have transformer less configurations and transformer based configurations also. The state of art review on Z source networks is tabulated here. So here NOS is the number of switches, NOC is the number of capacitors, and as you would have guessed by now, NOL is the number of inductors, because Z source itself has L and C involved. So number of capacitors and number of inductors determines the topology of the Z source network considered. That is, we have different structures here, and for different structures, the features are listed. Usually now what we are preferring is switched Z source type, which is a form of improved Z source topology. This is a generic structure of PV inverter grid structure. This is taken from ABB site. So here we can see the modules which we discussed so far, the PV system, the converter part, and the grid part, even before that, the PV inverter. So here, if we observe, the PV grid inverter configurations, they are available in 3 scales, that is small scale, medium scale, and large scale. On the large scale, we get the highest efficiency. That is known fact for us. When we go for buying in a wholesale shop, we get more goods for the same cost that we spend. But when we go for getting it from a store, obviously the cost increases. The same way, when we go for operating our inverter at a large scale, that is for generating more electricity, the efficiency part is going to be the highest. We are extracting more kilowatts of electricity. So usually for large scale, we use multi-level inverters, and the switch type used is IGBT. MOSFETs and IGBTs can be used on a medium scale, but for large scale applications, generally, we prefer IGBTs. While connecting with the grid, as I told earlier, there are numerous conditions involved, and grid synchronization needs to be properly done. So here, some standard international codes are listed. During grid connection, these are the international codes we need to adhere to. We need to follow these standards. And EMI, that is electromagnetic interference, low voltage right through. For each and every category, some international codes are listed. So anybody who is interested in generating electricity through PV panels need to follow this IECs, otherwise they will be penalized. They have to pay a penalty to the electricity providers. Now, we discussed about the basic blocks, and we saw that advanced control techniques are in research these days. So what are these advanced techniques, computational intelligence techniques utilized? Some of them, as I mentioned, are artificial neural network based and fuzzy logic based and multi-agent systems. The computational intelligence needs to be this type. For in advanced research, we are using advanced controllers. Usually, we use standard controllers like PI controllers, P controllers, PID, that is proportional integral derivative, proportional controllers. These kind of controllers we use. We also use hysteresis controllers. So now a lot of research is taking place on optimization. Whoever wants to go for doing research, they are looking out for latest optimization techniques like gray wolf optimization or beehive optimization. There are many more optimization techniques which have a specific objective function defined, and the way the convergence take place is slightly varied in each type. Coming to the classification of this optimization, if you consider the exact optimization means it can guarantee to find the optimal solution. So here, if you see the objectives as well as, that is the objective function, and your constraints, that is the conditions at which the operation should be done, are to be known quantitatively. That is, it cannot be vague. The exact value needs to be known. That is exact optimization. And you can further classify it into deterministic, robust, and stochastic. So coming to this deterministic optimization, here it is based on precise inputs, that is exact input, and it will produce the same output for a given set of inputs. That is deterministic. We can determine the output required. So whatever input we give, based on that, the exact output will be provided. And coming to the stochastic model, the variables are going to be treated as random here. And in robust is an important subfield because it deals with uncertainty in the data of optimization problems. So it will assume parameters to lie within some bounds. Coming to heuristic optimization. So what is this heuristic? Heuristic means it is a computational procedure that determines an optimal solution by iteratively trying to improve. It will go for iterative methods to improve a candidate solution with regard to a given measure of quality. That is, this heuristic optimization, it works on an iterative procedure. Further, it is classified as population and non-population based. So under population, the most popular algorithms are genetic algorithm and particle swarm optimization techniques. And under the non-population based, taboo search and simulated annealing types are most common. This population based is actually the quality of the solutions. It depends on the selection of algorithms. So the population based means we are going to feed it with exact data. Now, we have discussed the layout of our standard PV grid connected system. We discussed the PV system, the converter, inverter, as well as the grid, and some of the control techniques and optimization algorithms available. Now we get into a very important aspect of our discussion, which is energy storage. What is the need for energy storage system? Like how we discussed earlier, the energy which is available from renewable sources is not continuous. It is intermittent in nature. That means due to this unpredictable and fluctuating nature of solar power, we need energy storage. Even during the non-availability, we need to go for meeting our load demand. There should not be any discontinuity in this process. So we need energy storage. And for this, we are utilizing batteries. This is what is commonly done. For that, we need to go for a battery management system and a battery energy storage system. What is this battery management system now? When we use batteries, the charging and discharging of the batteries need to be monitored carefully. Otherwise, it affects the battery life as well as the connected devices. So for that, we use a battery management system, which is a crucial device to monitor. It will also regulate and it will safeguard the batteries. Generally, we use lead acid batteries and lithium ion batteries. Mostly in the market, lithium ion batteries are popular. These are some of the types of batteries. How this battery works, we all know it is because of the electrodes and the flow of electrons between these electrodes, that is positive and negative electrodes. So the chemical energy is converted into electrical energy in case of a battery. Now coming to the energy management, which is the last part of the discussion of today's presentation. Energy management is a key area which we need to look at. The generation of electricity is one part, but managing it effectively is the most important part. So even though we generate the electricity, if the efficiency is poor and if it is not able to meet our load demand continuously, if there is no continuity in supply, if our battery is failing to be acting in an efficient way, if our battery life is reduced, there is no point in going for generating energy even through renewables. So here in this figure, what we can see is solar panels, inverter and grid, what we discussed already, and the energy management system. Now there are numerous apps available for energy management these days. Why we go for battery management is because we need to go for battery protection, battery monitoring, and the communication between the components involved in the network. So for this reason, we have to go for battery management whenever we use batteries in our grid connected system. And some of the protection functions which this battery management system will do is it will go for over voltage protection, it will go for voltage protection, current protection, and over discharge protection also. Here, there is one interesting index which we need to look at, which is SOC, state of charge. State of charge management is also a key research area these days because battery state of charge determines the life of it. So how effectively the state of charge of the battery is maintained, like how even now we say it is advisable to switch off our mobile phones and charge the battery only for a limited duration of time and disconnect it from the charger. This we have heard, right? Why? Because we don't want our battery to be overcharged and lose its performance. We need to charge it only until it requires. So same way, the state of charge means even though there is excess power and we want to store it in the battery, it can hold only up to say 80% of the power. So coming to the temperature regulation and fault detection, all these kind of functions are performed by our energy management system. So during the day, solar energy will provide the electricity to the loads. And if battery voltage is higher than the higher SOC limit which we have fixed, then the algorithm will switch to battery mode. Suppose we do not have excess energy, then the solar panels need to power up our loads. This is about the battery management. So there are numerous apps available now for energy management where smart meters are there, where we can observe the power consumption and we can go for managing our power needs effectively. So I would like to conclude my presentation by saying that the renewable energy is booming these days, and it is better for us to move towards the world of renewables where carbon emissions are limited and we are able to go for utilizing our natural resources which are abundantly available instead of using depleting resources which are harmful to us. Thank you.
Thank you, madam. Thank you very much. Excellent talk, madam.
Thank you, sir. I think I have taken much time.
No,
So,
madam. No, madam. You are on time only. You are on time because
okay,
we gave your time only after 5 or 10 minutes. So it is compensated very well. Thanks a
sir.
lot, madam. Thank you for giving a wonderful talk, and that too the need of the day, the renewable sources of energy, and you have given a lot of insight to the need why it is warranted to think about and implement on renewable sources, and I hope that will promote us to reach. The 2030 target of cutting the carbon emissions. It was really very wonderful and interesting talk, madam. I hope
Thank you for the opportunity, sir.
participants would have enjoyed. Now, it is open for discussion. Delegates can ask any questions. Delegates, if you have any questions, you can ask Dr. Kavya, madam. Okay, if